We are now on the analytical geometry section of this paper, and we start off with question 3, which says, in the diagram, A, which is 4 and 2, B, which is 6 and -4, and C, which is -2 and -3, are vertices of triangle ABC, as we can see over there. And T is the midpoint of this line CB. Okay, so this is equal to that. And then they tell us that the equation of AC is 5x minus 6y is equal to 8. Okay, so it's just not in its standard form, but we have the equation of AC over there. We should probably put that down. Okay, so AC is this, 5x minus 6y is equal to 8. Okay, then they tell us that the angle of inclination of AB is alpha. As we can see, the angle of inclination, the angle it creates with the x-axis. And then triangle DCT over here is drawn such that CD is parallel to BA. Okay, those two lines are parallel, so we will see the kind of fun angles we can find on them. And then the lines AC and DT intersect at S. Okay, just an intersection. The y-intercept of AC, okay, that is also a y-intercept. PF and R are x-intercepts of D, AC and AB respectively. They're just naming all the x-intercepts. This is analytical geometry, so it will be useful. Okay, so the first question is calculate the gradient of AB. Okay, let's look at that. AB is a line with both points, okay, and the coordinates are there. So we can just use the gradient formula to find the gradient of AB. So the gradient is equal to y2 minus y1 over x2 minus x1. Formulas are in the formula sheet. So gradient of AB is equal to, just be consistent. So I'm going to go top minus bottom. So y2 minus y1, that's 2 minus -4, which gives you 2 plus 4, okay, because minus and minus give you plus. And then over, we have top minus bottom again, 4 minus 6, okay, so 4 minus 6, and let's just put that down, 4 minus 6. So that's going to give us, you know that on top you're going to get a 6, and then on the bottom you're going to get a -2. 6 over -2 gives you -3. So there we go. Gradient of AB is -3. Moving on to the next question. And 3.1.2, of course, they're asking us for the size of alpha. Okay, remember that we have the gradient now of this line AB. This is the angle of inclination of AB. So use the angle of inclinations formula, which is that tan of your angle, we'll just call it alpha straight away, is equal to the gradient. So the line we're referring to is AB. So tan of alpha is equal to the gradient of AB, which is -3. And so we can find alpha like this. Alpha is equal to, and you're going to take tan over so that you can let alpha be on its own, and it becomes the second function of tan, okay, which looks like this. But of course, on your calculator, when you calculate this, you will see that you're going to get a negative angle, and it's fine. Shift tan -3 gives you -71.56. And you don't want that because, as you can see, alpha is a positive angle, okay? So it's just been measured the other way around. Okay, so that's that. So to get that angle, you can just add 180 degrees, because remember that angles are measured anti-clockwise, okay? So that's the way to measure angles. So this is negative, so it was measured clockwise. So that's why it's -71 point something. So to make it positive, remember that this is all on a straight line. So just add 180 degrees to it, okay? So it will get to this point and 0 at this point, and once it gets to here, it's positive, and that's how you end up with a positive angle. So we just add 180 degrees to that. Okay, so here plus 180 degrees and we'll get our answer. So just add 180 and it should be fine. And that gives us 108. So alpha is equal to 108.43 degrees, and that's our answer. Okay, moving on to the next question. The next we have to find the coordinates of T. Okay, so where is T? Okay, T is the midpoint of this line. So we're just going to use the midpoint formula to find that midpoint, that's all. Okay, so our points are C and B. Let's write them down and use the midpoint formula. Okay, so that is what we have. And t, to find t as the midpoint, it is x1 plus x2 over 2, and then y1 plus y2 over 2. Okay, just a half of all those. Then let's go ahead and substitute this. This is going to be negative 2 plus 6 over 2, and negative 3 plus negative 4, which just gives you a minus 4, okay, because positive times negative is negative, over 2. Okay, and just simplify, that's all. So t is equal to 6 minus 2 is 4, 4 divided by 2 is 2, and then negative 3 minus 4 is negative 7 over 2. So there we go. That is our answer, 2 and negative 7 over 2. Moving on to the next question. The next thing we have to find is the coordinates of S. Okay, so let's just see, where is S? What line does it belong to? S. Okay, so that's why it's always important to write down things that you have. You see that on the line AC lies this point S, and S is the y-intercept. Okay, so if you put this in standard form, you'd be able to see that y-intercept. So that's exactly what we're going to do. Let's write down that equation and put it in standard form. Okay, so to get it in its standard form, we need y to be left alone. So let's leave negative 6y first. We'll take that 5x over and it becomes negative 5x, and this is still positive 8. Then get rid of the negative 6 by dividing both hand sides by negative 6. Therefore, y is equal to 5 over 6x, and then these divide. Now, they can actually simplify. Sure, it's going to be negative, but the common factor, highest common factor between 8 and 6 is 2. So if you divide both by 2, you're going to be left with negative 4 over 3. And there we go. So that means your y-intercept, because it's in the form of y is equal to mx plus c, and c is your y-intercept, your y-intercept is negative 4 over 3. So that is S. So the coordinates of S is, the x value is going to be 0, and the y value is negative 4 over 3. And there we go. Just remember, you could also have done this by simply, because it is the y-intercept of this line, you could have also substituted in place of x, you could have substituted 0, because to find the y-intercept, you make x equal to 0. And you would have also found it like this as well. That would have become 0. This would be negative 6y is equal to 8. Divide both sides by negative 6. Again, y would be equal to negative 4 over 3. Okay, so 2 ways of still dealing with that question. Okay, moving on to the next question. Next question, 3.2 says, determine the equation of CD in the form of y is equal to mx plus c. Where is CD? So CD is over here, right? What do we know about CD? Well, we know that CD is parallel to AB. So these two are parallel. And so we can actually find its equation, because if they are parallel lines have the same gradient, okay, because they're slanted in the exact same way. They have the same slope. So the gradient of AB is the gradient of CD. And you see that we have a point on CD. We have C. So we can use that. Okay, so let's just start with saying the gradient of CD is whatever the gradient of AB is, which is negative 3. We found that in the first question. So the gradient of CD is also equal to negative 3. And we saw we had that point negative 2 and negative 3 as C. So we can find the equation. So I'll just use this way. Y is equal to mx plus c. And then in place of m, we'll say y is equal to negative 3x plus c. Substitute your x and your y value, okay, into those coordinates. So that's negative 3 is equal to negative 3 times negative 2 plus c. Those give you positive 6 plus c. And this is negative 3. Take the negative 6 over, so negative 3 minus 6 is equal to c. Therefore, c is equal to negative 9. And so the equation of this line is y is equal to negative 3x minus 9. Okay, moving on to the next question. We are now on question 3.3, which says calculate the size of angle DCA. Okay, so angle DCA, let's just find out where that is exactly. Angle DCA is over here. So this is what they want us to find, the size of this angle over here. Okay, so let's look at the diagram and see how can we find it. Well, there are numerous ways to find it. If you look at it like this, Okay, I know they gave us parallel lines and we did use that, and maybe it's going to be helpful. But we could do that whole thing of constructing an x-axis, right? An imaginary x-axis, and then trying to relate the angles that we have with these lines. Okay, so like finding the angle of inclination there, so that will be part of DCA, and then finding that little part underneath here. But that seems complicated. It actually depends on the mark allocation. It's 4 marks, which is probably a 2-step process. So no, let's actually not go with that. Let's see another way that we can actually find this. Okay, so look at this. Since these lines are parallel, right, it means that we have alternate angles here, right? So this angle is equal to this angle. So whenever we think about DCA, we can just focus on this angle, angle A over here, okay, because that is alternate angles and they're equal. So let's find this angle. Now I'm seeing a whole lot of things that we can use in this region, because you see that we have alpha, and alpha is actually an exterior angle of this triangle, okay? Alpha is the exterior angle. And we know that the exterior angle, okay, alpha, is always going to be equal to the sum of the two opposite interior angles. So if this is what they want us to find, we already have this angle, then we just need this one, which does not seem difficult, because you see that this line AC is over here, and that angle is just the angle of inclination of that line. So let's go ahead and find the angle of inclination of line AC, and then we'll be able to use that exterior angle rule to find this angle, angle A, which is of course DCA. Okay, so first, to be able to use AC, we need its gradient. Do you see that we already have the equation of AC, and we already found the gradient as well? So the gradient of AC, when we're working on it, it's over here. Do you see that the gradient is here? Okay, so actually dealing with this like that would have been very helpful. So that's 5/6. So we can tell them that the gradient of AC is equal to 5/6. And then let's use that. So remember, we're trying to find the angle of inclination of line AC. So what is that angle going to be? So we're going to use the tan of theta is equal to our gradient. So tan of theta equals 5/6. And then theta is equal to, we'll take tan over. So it becomes the second function of tan, and 5/6. Okay, so let's see what that gives us on our calculator. If you say shift tan 5/6, we get theta being 39 point. Now just round off to 2 decimal places here. And the reason I'm going to do so is because we're just working with whole numbers throughout. Okay, we already have this one rounded off. We have the final answer of that. Okay, and so we can use that rounded off. It's not going to affect your final answer. Okay, so we know what that is now. Okay, 39.81. So we can just fill it in there. This is 39.81 degrees. And if that is what this is over here, remember the exterior angle of a triangle is equal to, so alpha, whatever that is equal to this plus that. Okay, so we can actually just write it down first. Well, we know what alpha is. Alpha, we already found that, so we can just put that down in place of that. It is 108.43 degrees. So this means the exterior angle alpha, 108.43 degrees, is equal to the sum of the two opposite interior angles. So it's equal to 39.81 plus, of course, angle A. And so to solve for angle A, you're just going to take that over. So the equation is really just angle A is equal to 108.43 degrees minus 39.81. Okay, so let's go ahead and find that, which is equal to 68.62 degrees. Okay, and then again, remember that that is exactly what DCA is because of alternate angles. So angle DCA is also equal to that 68.62 that we just got as well here. Okay, 68.62. So we have those now because of alternate angles. As you can see, a Z over here. So these two are equal. Okay, so we'll just tell them that, and then that is the answer. So therefore, this is equal to 68.62. And we don't need reasons because this is Euclid. Okay, so that is our final answer. Moving on to the next question. Okay, 3.3.2, the last question for question 3 says we need to find the area of POSC. Okay, so let's draw that out, see where that is, and find this area. So POSC. Okay. So with POSC, as you can see, this is not really any shape that, we can name. It's not a trapezium. If it was a trapezium, then you would have had two, sides being parallel. But we don't, okay? That line is slanted. This is the y-axis. So it's not going to work out. Okay. So what we can do in a situation like this is break up the shapes that you can see here. So what we can do here is construct a line going like this, a horizontal line. And now we have created a trapezium on top and a triangle on the bottom. See, this is not a rectangle because this line is slanted. It's not parallel to the y-axis. Okay. However, the x-axis and this line would be parallel since I'm drawing a horizontal line. Okay, a flat horizontal line like that. Okay, so that's of course perpendicular. So this is a trapezium and this is a triangle. Okay, so we just need to know the area of a trapezium to be able to work through this. Let's actually just get this down so we don't have to scroll up and down. Okay, so with this shape, what we can do here is this. The area of the trapezium, to find that, the area of a trapezium is really simple. This is how it works. It is equal to, so we're going to say A plus B over 2 multiplied by H. And really what we're doing here is the A and the B is really just the top and the bottom of the trapezium. So where you see you have parallel lines, this can be our top, like if it was flipped around, okay? This can be our top, that is our bottom, and then the height of the trapezium is that perpendicular height. So this one over here, that is your height, okay? So that's what we can just really look at. So the A and the B is really just the top and the bottom. So we can take that as the top and this as the bottom. I'll leave this specifically as the bottom since it's also the base of this triangle. And then the height is just the perpendicular height. So it's that OS over there. Okay, so those are really just what we need to find. We have to find the length of A, the length of B, and the length of OS. Okay, so since A goes from the origin all the way to P, and as you can see, P is on the x-axis. So this just means that this P is the x-intercept of this line CD. Now, remember we had the equation of the line CD. That's all we really need. If we can get the equation, this is the equation of the line CD. Y equals negative 3x minus 9. We just need to find out what exactly its x-intercept is. Okay, so y equals negative 3x minus 9 and find the x-intercept. So the x-intercept is the point where y is equal to 0, or it's a point where y is equal to 0. So make y equal to 0 and we can take negative 3 over. So 3x equals negative 9. Then divide both hand sides by 3 and therefore x is equal to negative 3. So now we know what that is. So it means that this point over here, the x value is negative 3. Which really just means that you went from 0 all the way to negative 3. You went 3 units to the left. So the length of A is 3. Okay, so we know that now. A is 3 and we can just find B as well. So B is a little different because it's not the x-intercept. However, do you notice that B, right, the length of B, where it starts from is from this point S on the y-axis. If you're going from S on the y-axis all the way to here, then what it means is that you see the y value that you have here. You have an x value and you have a y value, okay, negative something. That y value is going to be this same point's y value as well. So this point is also going to have the same y value here. So it's very important to actually find out what S is, which we actually did find out. We found out the point S was an x-intercept, okay, of two lines. And there we go. It's negative 4 over 3. Okay, so we know what that is. This is negative 4 over 3, making this y value also negative 4 over 3. And so this is very helpful because it lies on the line CD. Okay, and we have CD. We already found the equation of CD. Okay, line CD's equation is still this. So this time with CD with y equals negative 3x minus 9, what we're going to substitute so that we can find out what exactly the length of B is. How far are we going from here all the way to this side? Okay, we really just need to know what exactly that x value is. Then we will know exactly how far this is, okay, or the length of that. So we're going to substitute that into the y value, right, in that line CD, and we'll find what exactly that x value is. So negative 4 over 3 is equal to negative 3x minus 9. Okay, so at this point, we can take the 3x that over, and this comes over and also becomes positive, and minus 9. So you can see to calculate them, we can call this 27 over 3 because we'll multiply the numerator and denominator by 3. And then 4 minus 27 is 23. So negative 23 over 3. And then divide both sides by 3. Divide by 3. Divide by 3, which really just means to multiply by 1 over 3. And so x is equal to negative 23 over 9. Weird number. Okay, but that is the value of x over here. So now we know that this is negative 23 over 9. We know the base as well. This is also the bottom of this trapezium. So that is going to be, you see, you're going from 0, right? From x being 0. And you're going to the left where x is equal to negative 23 over 9. So that means the distance is 23 over 9 because you just went 23 over 9 units to the left. Okay, so we know that and we know that. And that is enough to find the trapezium. With the triangle, we would need one more thing, which shouldn't be difficult to find as well. Okay, it's better to just find it all at once. So with the trapezium, we've got the top and the bottom. That's good. Now we just need, with the triangle, what can we use here to find the area of this triangle? Remember that the area of a triangle is equal to half base times height. Okay, we already know the base here. So we might as well find the height. Okay, the height would be from the highest point of the triangle down to the perpendicular base. Okay, so be perpendicular to the base. The height is perpendicular to the base. And we already know the y value of this. Okay, the y value is negative 4 over 3 all through here. Okay, so we have a negative 4 over 3 here. And then we can see that the y value at the highest point of this triangle is negative 3. Okay, that is negative 3. So what exactly is your height? How would you find your height? If the base is at negative 4 over 3 and the highest point is at negative 3, then just subtract them to get the height. Okay, so you'll say negative 4 over 3 minus negative 3, and you'll find your height. It's always highest minus lowest. Okay, and that gives us 5 over 3. So we know the height of that. It's 5 over 3. Okay, we have everything we need now to find the area of this shape. So this is how we're going to find it. Instead of finding each of these individually, let's just put it all together as one. So we can say the area of this shape POCS is equal to the area of the trapezium plus the area of the triangle. And we know we find the triangle by saying a half times the base times the height. Okay, which is the same thing here. So it's equal to, except for the heights, of course. So we can call this height H, big letter H. And then we have A plus B over 2. So the A value is 3. The B value is 23 over 9. So 3 plus 23 over 9 over 2 multiplied by the height of the trapezium. And we can see that the height of the trapezium, like we spoke about, is 4 over 3. Okay, because it's just highest minus lowest of that. So 4 over 3 multiplied by 4 over 3. And then let's just work on the triangle. So this is one calculation. This is another one. Okay, so a half times the base here was exactly the same. It was also 23 over 9 multiplied by your height. Okay, so a half times your base of 23 over 9 times the height, which we found of the triangle, which was 5 over 3. So 5 over 3, and then we can find this. Okay, so if you put this all together, it should give you the area of this shape, Okay, so this is what we get when we multiply everything. So we get 35 over 6, which if we simplify is equal to 5.83 units squared. Okay, so that is the area of that shape. Now, there are definitely other ways to find the area of that shape. So as long as you get to this answer, then it is correct. Okay, we can just look at the diagram to really just scan for this. Let's actually look at this diagram. So if you wanted to use another way, okay, trying to find the area in another way, there's also this option. So you could look at it like this. Do you see that you have a bigger triangle here, right? And if you erase this triangle from it, you'll be left with that same shape again, POSC. So if you took the bigger triangle, the area of the bigger triangle minus the area of that smaller triangle, you would also end up with that. Okay, so that's one other way. And of course, you can find these dimensions because you see that 39.81 degrees is here. It's vertically opposite this. So this is your angle. Then you could have used the area rule from trigonometry to find the area of this triangle, as long as you have the sides PF and the sides CF, okay? Then you'd be able to use that. Okay, for now, those are the two ways that I've got. I'm sure there are other ways as well. So you guys can actually mention that in the comments, to help others who are looking at this paper and also just thinking of other ways they could have found the area of the shape. Okay, so that is it for question 3. And we move on to more analytical geometry in question 4. Okay, we're on question 4, which says, in the diagram, M is the center of the circle, having Pn as its diameter. And we have KL is a tangent to the circle at N, as we can see over there. So they tell us to calculate the coordinates of P. Okay, so this is just a midpoint situation because this is the center of the circle. So this is a radius and this is another radius. So since this is one of the endpoints, it means that this is the midpoint. Okay, so we're going to use the midpoint formula here. And we'll remember that this is just one of the endpoints and not the actual midpoint we're looking for. Okay, so the midpoint formula looks like this. It's x1 plus x2 over 2, and then y1 plus y2 over 2. Now, our x1 and our x2 we have to establish because this is just p, we'll call it x and y. This will be our x1 and our y1, okay? Now, the reason why is because remember, this is your center. This is your midpoint, okay? This is the calculation to find the midpoint. So don't label this as x1 and y1 or x2 and y2 because this is the actual midpoint. If you label that as x1 and y1, you're going to find the midpoint of this little line, mn. Okay, so we have that and we're just going to substitute it in. So we already know what the midpoint is. It is 3 and negative 5. But to find the midpoint, we use this. So x1, which is x, plus x2, which is these ones, and I didn't name them, x2, y2. So that is plus 7 over 2. And then y1 plus y2, which is y, plus negative 2, which is really just plus, and negative just gives you negative. So minus 2 over 2. Okay, so now that we have this, we have the calculation for the midpoint and then the actual midpoint. They really represent the same thing, the midpoint of this line, that diameter. So we can equate them. Since this is the x values, we'll equate the x values as 3 is equal to x plus 7 over 2. And these are the y values. So we'll equate them as negative 5 is equal to y minus 2 over 2. Okay, so now that we have that, let's go ahead. You see there's a 2 on the denominator that's stopping us from getting to the x. So to get rid of it, we'll multiply both hand sides by 2. And so this now becomes 6 is equal to, the 2's here cancel and you have x plus 7. You take the 7 over, you're saying 6 minus 7 is equal to x. Therefore, that means x is equal to negative 1 over there. And then the y values here, we'll do the exact same thing. Multiply by 2 to get rid of the 2 as the denominator. Negative 10 is equal to, those cancel, y minus 2. Take the 2 over, so that's positive 2 minus 10 is equal to y. Therefore, y is equal to negative 8. And so your endpoint, which is this point P over here, is negative 1 and negative 8. There we go. So negative 1 and negative 8, and we can just fill that in so we know that we already have this point, negative 1 and negative 8. And that is it for 4.1, and we move on to the next question. The next question, 4.2.1, says, determine the equation of the circle in this form, okay? In the form of the equation of a circle. So to find the equation of a circle, all we need is the middle, right? The center of the circle, and one other point, which we clearly have throughout in that circle there. Okay, we've got 2 points to choose from. Choose the easier point. Okay, so I'm just going to go ahead and use the midpoint, of course, the middle, the center, and I'll use n. Okay, so let's go ahead and do that. So we're going to already write it in that format, but we just need those points to be here. Okay, so our middle or center is M. So we're going to call that A and B. Okay, so this is A and that is B. And that's what we're going to substitute first. So that is going to be x minus 3 all squared plus y. And then you see it's minus a negative 5, which is going to become plus 5 all squared is equal to r squared. Now to find the r squared, we would substitute these points. So this is going to be our x and our y value because it's just a point on the circle. Okay, so that is going to be 7 minus 3 all squared and then plus, and the y value is negative 2. So we say negative 2 plus 5 all squared is equal to r squared. And then you can just sub this onto the calculator just so that you can get r squared straight away. Okay, so when we put it in the calculator, we get 25. So 25 is equal to r squared. And then now that we know what r squared is, we can finally write the full equation. Therefore, okay, so remember that this was the equation that only needed r squared. So we just substituted into that. So x minus 3 all squared plus y plus 5 all squared is equal to 25. And that's our answer. Okay, so that's the equation of the circle. Moving on to the next question. The next question, we have to find KL. Okay, so the equation. The equation of KL in the form of y equals mx plus c. So KL is that tangent that we have over there. Okay, let's find the tangent. So to find the tangent is a straight line. So it's in the form of y equals mx plus c. So really all you need is a gradient and the y-intercept. So to find the gradient, sure, there's no other point on KL. However, there's something we know about the radius and the tangent at the point of contact. The radius and the tangent meet at 90 degrees. So because this line is perpendicular to this line, we can actually find the gradient of KL. Okay, so let's focus on finding that gradient first. So we need the gradient of the radius first. So we need m and n, and then we can go ahead and find this. So we already wrote m and n down. Let's just find the gradient of that first. So gradient of mn is equal to, and it's y2. Well, we already have that formula, so we might as well just put this as it is. So that is going to be the y value. So we'll just say top minus bottom. So negative 5 minus negative 2, which is positive 2, over 3 minus 7. And what does this give us? Okay, so that's going to be a negative 3 on top and a negative 4 on the bottom. So that's positive 3 over 4 at the end of the day. Okay, so if this is the gradient of the radius, right? Then remember that with perpendicular lines, the gradient of the radius of mn, the gradient of the radius multiplied by the gradient of the tangent KL, right? It's going to give you negative 1 because those are perpendicular. Okay, so with this equation, do you see that to find the gradient of KL, you would just have to divide both hand sides by the gradient of mn, and that would give you the gradient of KL. Okay, so mn. And then, so we know now that to find that gradient, we'll just say negative 1 divided by that other gradient. Okay. So therefore, the gradient of KL would be found by saying -1 over the gradient of mn, which is really -1 divided by that. And if you divide this number by -1, it's just going to switch over and get multiplied by a negative, which is -4 over 3. And that is the gradient of KL. So now that we know the gradient of KL, we can just find its equation, because do you see that KL, right, it has a point on this line. So we're going to use that point to find the full equation. So y equals mx plus c, we know what m is. Y is equal to -4 over 3 x plus c, and then substitute an x value. The only x value we have to substitute is n, which is 7 and -2. So n being 7 and -2, and this is x and this is y, so that is -2 is equal to -4 over 3 times 7 plus c. Okay, c is finally equal to, do you see that if you multiply these, they become negative. If you take them over, they'll become positive. So here they're going to be positive 28 over 3, because 4 times 7 is 28. So -2 is equal to c. Okay, so that's how we find c. Therefore, c is finally equal to, they just have to both be over 3. So what's 28 minus 6? That's going to be 22. So 22 over 3 is going to be your y-intercept. Therefore, the equation of this line is y is equal to, I'll just put it here, okay. Y is finally equal to -4 over 3 x plus 22 over 3. And that is our answer. Okay, so that is the equation of KL. Moving on to the next question. Okay, we are on question 4.3, which says, for which values of k will y is equal to -4 over 3x plus k be a secant, okay, to the circle? So you see the equation they're using, the line that they're using. Okay, so that line with a gradient of -4 over 3, which we now know is this tangent. Okay, it's not this exact tangent, but yes, they're just trying to see if you have this line, right? For which values of k will it be a secant if k is that y-intercept? Okay, so let's think this through. How can we make it a secant? Well, first of all, we need to understand what a secant is. We have a circle and you have a line cutting through the circle, okay, where, as you can see, it cuts through the circle at 2 points. Then this is known as a secant. Okay, this is different from a chord. A chord would really just go from one point on the circumference to another point. Then that is a chord, and for it to also be a chord, it must not pass the center of the circle. However, with a secant, this is different. Even if the secant passes the center of the circle, as long as it extends out like that, it's a secant. Okay, so, and it wouldn't be a diameter, because a diameter would not have those endpoints. Okay, so it will just be like that. So that's really what we're going to look at. So let's look at that. And we know that the line with the gradient of -4 over 3 is this tangent. So for which values of k, if we're looking at y is equal to -4 over 3 x plus k, for which values of k would it be a secant? Okay, if you look at this, right, since we're looking at k, y equals -4 over 3x plus k. K is a y-intercept. So the only way you can manipulate this is through the y-intercept, meaning you can either move it up or down. Now you see when you move it up, that is a bad idea because it doesn't even touch the circle anymore. So it can't be a secant. But if you move it down, then you start seeing it's a secant. Okay, I made the line thinner so you can see this. So if we move it down, it's still a secant. See, it cuts through the circle and it passes 2 points. Okay, so still doing the same thing. If you keep moving it down, it's still going to be a secant until it gets to this point over here where it will be a tangent. And then if it goes beyond that, it's no longer intersecting with the circle. So we need to find the values of k for which the graph is going to exist for all these places. Okay, so we know we're moving it down, right, from where it is, from this point over here. We would have to consider what exactly would k be at this point. So if this is your tangent, what is k? What is your y-intercept? Remember, this line would extend upwards, so it's going to intersect with the y-axis somewhere up here. And once it intersects, that's the k value. So we will need to find that first. Let's find that y-intercept first. Okay, so since we know that this line, right, at this point where it is a tangent, right, that is the point where k is equal to, we already found that because we found the equation of KL. So we already know at what point k should be a tangent to the circle. So that was here where we found this already at this point, okay? So it's going to be a tangent where k is equal to 22 over 3, right? So we know what that is. That is 22 over 3. And then for it to be a secant, it must be anything less than 22 over 3. But then it can't just be less than 22 over 3 and it just goes down forever, because then at some point it's not going to be a secant anymore. So we can see that the place that it should stop is here, because at this point it will also no longer be a secant. It would be a tangent at this point. So all we need to find out is what exactly is the y-intercept when this line intersects this point P. That's really it, because at this point P, it would be a tangent, not a secant. Okay, which is actually okay to find. So we look at it like this. We already know the gradient of this line. It's negative 4 over 3. And we know it's intersecting P. So now we can find out exactly what that y-intercept is by finding the equation of this line. Okay, so we're looking at a line with a gradient of negative 4 over 3 intersecting P, which is negative 1 and negative 8. Okay, so the gradient is negative 4 over 3. Okay, so let's find this. It's going to be y is equal to, I'll just use the quick way. So y minus y1 is equal to m times x minus x1. And then in place of m, we can just put in our gradient, which is negative 4 over 3. Okay, so let's substitute our x and y value. That's x1, that's y1. So that's y minus negative 8, which of course gives you a plus 8, is equal to negative 4 over 3 times x minus and negative 1, which is going to give you a positive 1. And then let's just simplify. So y is equal to, and if we distribute here, I'm just writing y because we're going to take the positive 8 over. So if you distribute here, it's negative 4 over 3x, and distribute, that's negative 4 over 3. Then if you take the positive 8 over, it becomes a negative 8. Okay, so y is equal to negative 4 over 3x. And what exactly is negative 4 over 3 minus 8? That gives us negative 28 over 3. Okay, so we know what that is. So we know what the y-intercept is. So here's the story. If you move that line, okay, from where it was a tangent, and you move it down, it becomes a secant. Secant here all through until it reaches this point where it's going to be a tangent again. So we needed to find out what exactly is the y-intercept, the value of k at this point. And now we found that that's negative 28 over 3. So this means that this line is always going to be a secant as long as the value of k is less than 22 over 3, but greater than negative 28 over 3. As long as it's within this region, it's going to be a secant. Okay, so we can actually finally put that down. So our answer, our final answer there is it's going to be a secant for the values of k where k is greater than negative 28 over 3, but less than 22 over 3. That's what we had there. And that is our final answer. Okay, so that is it for 4.3. And then we move on to the next question. Okay, final question for analytical geometry. We have points A and B. So A is made of T, and B are not shown in the diagram. From point A, another tangent is drawn to touch the circle with the center M at B. And then 4.1 says, show that the length of the tangent AB is given by this. Okay, I know they said they're not shown in the diagram, but for reference, let's just put it in the diagram so that we can understand what's going on. So let me get the diagram first. Okay, so this is the case. We have a point, right, called A and B, and they're not shown on the diagram. But they tell us that from point A, another tangent is drawn to touch the circle with the center M. So it's this circle at B. So what's going on is we have this circle, and then from point A, a random point, it could be anywhere, it could be here, it could be here. I'm just going to put it here. So another tangent is drawn from point A. Okay, so this is a tangent. It touches the circle at one point, and it comes from the point called A, right? And they say that, so from point A tangent is drawn to touch the circle with the center M at B. So the point of contact with the circle is B. That's what we have going on there, okay? And what they want us to do is show that the length of the tangent AB, okay, that length is given by this. So first of all, we can see that this is square rooted. So they could have maybe used the distance formula or Pythagoras, because those would be things that you would need to square root at some point. But let's see. So if this is a tangent, right, and it's drawn to the circle, it's a tangent at B, and we have to find what AB is. How would we do that? So this is actually one of those questions that you would find in a textbook. Okay, so I know it is in the Kevin Smith textbook. I have seen it there. It's probably also in the Mind Action series textbook, maybe Platinum. I'm not sure about Platinum. But you see, with this, what you're going to have to do is, because you're trying to find this length, let's just look at the problems that we'll have here. They told us that A, right, the point A is T and T. Okay, T and T. That's what we have there. So if you have to try to find AB right now, it's not going to be possible, because you're going from A to B. So B is unknown right now. B is just X and Y. So if you found it using the distance formula, there's no way it's going to give you this, because this is only in terms of T. It doesn't have any X and Y in it. So there's a little bit more that we have to do. So what we just did now is we ruled out using the distance formula, because using the distance formula was not too helpful to directly find AB. So we can't really just use the distance formula. Remember how I said that this has a square root? So it's probably the case that we are using the distance formula or the theorem of Pythagoras, because that will be a situation where you would have the square root at the end. That's probably where the square root came from. So let's actually see, can we form a right angle triangle with this tangent and the center of the circle, so that we can use Pythagoras on this? Okay, so let's see if we can do that. So we're going to draw a line, and it's going to be perpendicular, so for a radius perpendicular to that point of contact. And then do you see that because this is AB, for you to draw a right angle triangle that includes this length AB, you're going to have to connect the point A and M. And if you connect A and M, there you have a right angle. Okay, right angle triangle. Now, how can we use this right angle triangle to find the length of AB? To do that, you would need this side and this side. So now we can actually focus on that. What are the lengths of these sides? So with MB, pretty simple, because M to B is a radius. So it's just the length of the radius, which we already know is 5 units. Okay, we already found that out as we were working through these questions. It's 5 units. Okay, as you can see here in 4.2, you have the equation of your circle. R squared is 25, then R is 5. Okay, so we know what the radius is. It is 5 units. That is great. So the only thing we need to find now would be AM. Okay, so to find AB, we use MB and AM. AM is pretty simple to find, you see, because it's going from A to M. And this is in terms of T, and this is with numbers. So we can actually use the distance formula to find AM. So let's go ahead and do that first. Let's find the length of AM. Distance formula is found by saying the square root of, and you say x2 minus x1 squared plus y2 minus y1 all squared. So AM is equal to the square root of, and we can just, because they have like t squared, let's just start with the t, so A to M. So we'll say t, so first x value, or x2 minus x1, t minus 3 squared plus, and then the y value, so t minus negative 5, which becomes t plus 5 all squared. Okay, so this is what we have for AM. Great. Now, yeah, it looks funny, but it's fine. Here's why I say it's fine, because this is AM, right? But when you're going to use the theorem of Pythagoras, look at how it's going to work. So we can jump into the theorem of Pythagoras immediately to find AB. To find AB, Do you see that AB is not the hypotenuse? It's one of the shorter sides. So we say AB squared would be found by saying the longest side, the hypotenuse, AM squared, minus the other shorter side, which is MB squared. Do you see that we're going to square these? Okay, so that's why I said it won't really be a problem that this one looks like that. So we can even go ahead and square it from here, or we didn't even need to include the square root, honestly. So if you squared it, okay, then those square roots just break open. So we have AM squared is equal to, and we just have t minus 3 all squared plus t plus 5 all squared. Okay, now you have the choice to actually simplify this, which I think is a good thing to do. We can simplify that first and then work with the theorem of Pythagoras. So let's just pull this down here and then let's just clean this up. So this says AM squared is equal to, and let's go ahead and FOIL. So you can deal with this the quick method. So you'll say the first term squared, which is t squared, the last term squared, which is positive 9, okay? And then first term times second term is negative 3t, and then you times that by 2, which is negative 6t. Same thing on this side. First term squared is positive t squared, last term squared is positive 25. First term times second term is 5t, then times 2, which is positive 10t. Okay, so this is what we have. Therefore, AM squared is equal to, and the t's together, which gives you 2t squared. And then those together, 10 minus 6 is positive 4t. And then 25 plus 9, which is going to be 34. Okay, so that's what we have. Okay, not bad. We can actually work with that now. So remember, to find AB, we're saying AB squared is equal to AM squared minus BM squared. So let's just substitute. AB squared. AB squared is what we're looking for. So we leave it as AB squared is equal to, but with AM squared, we already found AM squared. It is 2t squared plus 4t plus 34. And then minus MB squared. What is MB squared? MB is 5. So when you square that, it gives you 25. So minus 25. And then we just have to simplify this. So we have AB squared is equal to, and this is 2t squared plus 4t, and then just subtract those. 34 minus 25 gives you positive 9. Okay, so that's what we have. And you see the final answer is to find the length of AB, not just AB squared. So to find the length, we're going to square root both sides. You don't have to include plus or minus because these are lengths. They cannot be negative. So it's equal to the square root of 2t squared plus 4t plus 9, just as they said it would be equal to. Okay, and I just noticed when you square root, sorry, that's going to give you AB. So that is the final answer. Okay, so that is it for that question. And moving on to the last question in analytical geometry. Okay, so 4.4.2 says determine the minimum length of AB. Okay, so we can do that. You see how this question really helps you? Because even if you didn't get this one right, you could have still gotten this one right. Because they gave you the length of AB already. They told you that it's going to be that. So, you would still be able to do that. Okay, so determine the minimum length. Okay, you want to find the minimum length. The length right now of AB is this, okay? That's square root 2t squared plus 4t plus 9. What do you notice about this and what is under the radical? Okay, what's under the square root is a quadratic expression. You can find the minimum length of this. So if you find the minimum length of the quadratic expression and you substitute it into this, it's going to give you the minimum length of AB. Because even if it's square rooted, it's still a minimum. So it's still the smallest length that you can have. So our focus is on this quadratic expression. We have to find its minimum value. To find the minimum value, remember this is really just a concave up parabola. And you want to find the lowest value that it can have. You just have to find the y value of the turning point, because that would be the lowest value. Okay, if it was on a Cartesian plate, that is the lowest values we'll ever have. Okay, So we can do that by deriving this, but you could also use this formula. X is equal to negative b over 2a. That finds the x value of the turning point. So x is equal to negative, and our b value is 4, over 2, and our a value is 2. So that's negative 4 divided by 4, which gives you negative 1. So we know what x is. We know what t should be, really. Okay, because this is in terms of t. So we know what t should be. And if you substitute this x value that belongs to that minimum turning point, you're going to find the y value, which is the actual minimum value. So we can go ahead and substitute. So AB is finally equal to the square root, and we'll say 2 multiplied by negative 1, and then plus 4 times negative 1 plus 9. Okay, so that's what we have. And then we can just find out what exactly this gives us. Okay, and the minimum length of AB is this. I forgot the square. So it's the square root of 7. That is the minimum length. Okay, so that is the answer to that question, and that concludes it for the analytical geometry section of this paper. And I will see you guys in the trigonometry section.